So the first one says weights of newborn children in the United States vary according to normal distribution with mean of 7.5 pounds, standard deviation of 1.25 pounds. Government classifies a newborn as having a low birth weight if the weight is less than 5.5 pounds. So this particular problem with A, if I were writing things off to the side like I did on Friday, what would I write beside of A? This is an individual. So is that chapter 7? No. So I can just go straight into P parentheses because of that. What symbol goes here if it's an individual? X. So this one is just X is less than 5.5 pounds.
What's the other option?
X bar. X bar or P hat, but in this situation, X bar. So I convert that to a Z-score. So it's 5.5 minus 7.5, and right now it's divided by what? 1.25, because I'm dividing by the entire standard deviation. And that gives me negative 1.60. So rewrite it in terms of that. And you end up getting a probability of about 0.0548. Just for the record, when you're looking at my answer keys for this test, I used to write the Z up here, but people would forget to write it a lot. So I switched and started writing it here instead. But just for my answer key's sake, this is going to be written up there, I think, in most of them. Okay, so part B instead is talking about a what? A sample. So anytime you know that it is a group of people, a group of being a sample, and I have to find something about where they fit in relation to the entire population, that's when I know that I have to do a 4-step. Because there are things that come along with having a sample that I have to check. So with state, where do I start? Population. What is my population here?
Chocolate bars produced by sublimation.
Oh, you're one off.
Oh wait, I'm on the wrong one. Never mind this.
So this one is all what?
All newborn children in the U.S.
So this one's very vague because it seems pretty much repetitive. What's our sample? The ones of those that are randomly selected. What's the next thing I write? What am I defining? Well, mu stands for what? And again, you can say the mean something of all newborn children in the U.S., or you could just say mu is the mean weight, because the mean weight of all newborn children in the U.S. And then find P parentheses what? So this being X bar as opposed to X is the same thing as saying, hey, we're doing a sample, which is again justifying the fact that we needed to do 4 steps. Go ahead and write as much as I can, just kind of keep scrolling up. So what's my first thing in plan? 10% condition. What is my equation for 10% condition? What does it start with? Capital N is, what is my lowercase n for this problem? 3, which means I'm making sure that my capital N is greater than or equal to. And so written out, I would say there are at least 30 what?
Newborn.
Essentially that right there, newborn children in the U.S. And so in some part of it says newborn babies, and some of it says newborn children, so I don't care about that.
We haven't yet, but are we ever gonna have a problem where it's like there's not at least?
Okay, so with this and with checking normal condition, it's not always the case that it works, but if I give you a problem and I'm like giving you a whole page to do it, or the AP exam gives you one, they're not going to do one that you stop. So it'd be like asked in a specific question by itself, like, does it meet the requirements, blah, blah,
So
blah.
like on our test, are they all gonna work?
I'm not going to give you one that I expect you to take a whole page on. It would be like, I'll ask you a piece of a problem. So I'm at normal. And here I thought I gave you two different types of normals for the homework problems, and I didn't. What do I write there? So it stated that this part right here is important. The population distribution. And sometimes it's going to say is normal, and sometimes it's going to say is approximately normal. That just depends on literally the wording of the problem. This one said normal. So what do I write right after that? So we can use normal approximation. All right, so now I'm going to do. What's the first thing I do for do? Equals mu, which in this case equals what number? And what are our units for this one? Pounds. So I've got mean. Now I'll go straight to what? Standard deviation. So sigma of x bar, which equals what? Sigma over squared n. What was our given sigma? What's our n? And so you end up getting about 0.7217. What do I need to write inside that? Because what? 10% condition. So now I'm going to solving what?
Did it tell us the sigma?
Yeah, it would have given it to you like in the
Yeah.
top problem. So P parentheses X bar now is less than 5.5. So now when I convert it to a Z, I've still got 5.5 minus 7.5. But now it's going to be divided by this number, which is 0.7217. So if I am taking a sample as opposed to an individual, is it going to be harder to get farther from the mean or easier? If I take an entire sample, is it harder or easier to get farther from the mean? Harder, because this is my spread, and my spread does what? My spread decreases, so it's harder to get farther away. That gives me negative 2.77. Is that what you're getting? And so now we're saying Z, probability Z is less than negative 2.77. We can go to our calculator and have it pretty much do this part for us. And we get about 0.0028. So all I have left is conclude. Which starts with if what? So if we were to randomly select How many? 3 what?
Newborn children.
When, and that's all I need you to write, and that's all my answer key's gonna say, but it's also technically that it's also, and sigma is 1.25. Then the probability, and this is where I would usually just take word for word for the problem. This one wrote it out really well. That their average birth weight is less than 5.5 pounds is about 0.0028. And then part C says, why are the probabilities in part A and part B not equal? Well, what is part A talking about? And part B is talking about an entire sample. We just talked about this. The spread of a sample, the spread of a distribution made up of samples is what? As opposed to this one. This spread is what in comparison to this one? Smaller. So it's going to change everything. Does anybody need me to go into more detail and see? Alright, so number 2. This is one about the chocolate bars produced by this particular machine. So our population here would be all, they're called 8-ounce candy bars, which is kind of annoying because that's also what we're measuring. So all 8-ounce chocolate bars produced by this particular machine.
Would it be okay if we just said chocolate bars?
On a test, I would want you to be more specific that it's from this particular machine. Oh, you're talking about just here?
Yeah.
If you just didn't put the 8 ounces, yes, I can argue with that. I've done one like this, and I call it something else, like a fun size candy bar or something, so that it doesn't get as confusing. Your sample here is kind of vague, like the last one was. It's the ones that were selected. And I don't like that they switch back and forth between chocolate and candy. And you wouldn't technically have to write it, but I would probably write it from this particular machine. Defining mu, which is the mean, what? What's our mean for this one? Which is technically the mean weight of all chocolate bars produced by this particular machine. But we've already defined population, so we're okay with that. And now we're finding P parentheses what?
X is less than 7.
And it's going to be X R. So plan, we're going 10% condition. Capital N is greater than or equal to 10 little n. What is our lowercase n in this case? So capital N has to be greater than or equal to what? We would say there are at least 40 what? And based off the way I wrote it, I would want to see chocolate bars what? Produced by this machine. What do I write for normal?
Stated the population distribution is normal.
Stated that population distribution is normal. So, what?
Use normal distribution.
Use no approximation. What's our first part to do? Which equals? Then sigma of x bar, which equals?
Sigma over
What's our sigma here? Well, square root 4, so I'm divided by 2, which gives me, what if Al says, what do I write there? So P parentheses x bar less than 7.85. I need to convert that. So 7.85 minus 8.1 divided by 0.05. And what do you get right here? If you're looking at your yellow sheet, why does that seem like an issue? There is no -5, which means what about the probability of it being less than -5? Is that going to happen very likely? It's almost 0. So if you do it in your calculator, you're going to get something like 2.87 e to the -7th. So that -7th means I'm going this way, 7, 2, 3, 4, 5, 6, which means there's 6 zeros in front of that number. Almost 0 is fine. Or it's 6 zeros, 287. Now, what if it said probability that z is less than 5? What would our answer be instead?
almost 1.
Almost 1. So just because it says a high number doesn't necessarily mean it's almost 0. It's still depending on what it asks you direction-wise. All right, and our conclude. If we were to randomly select how many?
4.
What?
Chocolate bars.
And I would say from this particular machine, when what?
Mu equals 6.
The probability, I think this one ended up being word for word too. Probability that the mean weight of the 4 candy bars is less than 7.85 ounces is almost 0. Or 0.000000287. I have questions with 1 or 2. And so number 3 was kind of vague. It didn't give you much of any numbers. It just said in scenario A, we're randomly selecting from this population and we're taking 15 of them. In scenario B, we're taking 45 randomly selected at a time. And it says the population distribution is right skewed. So what do I know about the center of my 2 distributions of selecting 15 at a time versus 45 at a time? Those are going to be the same. Because how do you find center? U of x bar equals mu, and mu is not affected at all by sample size. What is my shape in scenario A?
Follows the population. Gonna be right.
It follows the population, so it is still going to be right skewed. As I take bigger samples, so if I've gotten all the way up to 45, am I still going to follow the shape of the population distribution? It's going to become what instead? And more specific? More specific? So go ahead and go all the way to say approximately normal, even though what you guys are saying is right, that's just more specific. What's going to happen with my spread? The spread for this one is going to be what in relation to the spread from scenario B? This one is going to be bigger than that one. How much bigger was my population size or my sample size?
3. What does that say?
If I took my old sample size, I multiply by 3 to get my new sample size, right? So some of you can take this a little bit farther. How much, can you decide how much smaller my scenario B is going to be?
Why is B smaller if it has more?
So your spread gets smaller. Like as you have more, your spread gets smaller. It's more consistently towards the middle. Like that. It's like easier to get an individual with a value far from the mean, where it's harder to get a group whose average is that far from the mean because your spread is smaller. So if this was multiplying it by 9, what would happen to my standard deviation? It'll be divided by 3. So it's the what of 9? So technically here, I could actually write this that if this is my first standard deviation, this one is how much of my first standard deviation? What? Because of the same thing you just said. So like if this were 9 times, it's going to be a third of my standard deviation. So I'm dividing it by the square root of that. So I'm dividing it by the square root of how much bigger it was. But that's kind of a little bit of a step farther. You need to know this, that this one is bigger than that one. Questions with anything in the homework? While I'm recording, let's go ahead and talk about the test a little bit. The test is going to be super straightforward. This is going to be the first one where you should really, really, really know what to expect walking in. I am giving you 2 4-step process. Why am I giving you 2 4-step processes? One of them is, and one of them is. So one of them's done leads, one of them's done proportions. I'm still going to do multiple choice, but to be honest, it's harder to find multiple choice. So if we've done anything with multiple choice, use those as resources. I'm going to have, so right now I have it as 10 multiple choice. I'm pushing it to be able to get that. There's another problem that I have said a bunch that I'm definitely going to say this type of problem will be under test. Do you remember what that was? Define 4 things. So I give you a scenario, you tell me 4 things. Answer here, I would want words. Answer here, I would want words. What's an example of something of an answer that I would want for that? P equals, or mu equals, or sigma equals. What would be an example here? P hat equals, X bar equals, that kind of thing. This is the only part that you won't know 100% that it's on there. You know there's going to be two full 4 steps. There's going to be these kinds of problems. And I'm going to have some that are asking you some just generic short answer stuff of like quick problems that aren't multiple choice. It'll probably be quicker than most of our tests, especially, yes, these take the majority, but they get super repetitive. So hopefully y'all are getting a little bit quicker with those. Any questions about anything given the whole deal?
Will we have to like define the symbol?
I do not currently have that as a section, and I'm not going to. I'm trying to think it through it. If you don't know what they are, you can't do it. So like, I'm not going to ask you a separate question right now. Yes, this is a question. I'm not going to make you like define what the symbols are on the test. Any other questions you want to think about? Obviously, come up with them, ask them.